G'day there everybody. I finally dug out my 1 ohm resistors so I can give you some proper amps tests with my scope now. I'll just scale that back in because it's drifted off. We are losing a bit of power in this battery, it's pretty flat. So what we have here, the circuit is on, the transmitter is on, you can see that, I get a light. What we have here is 0.43 volts in the battery. And I have a 1 ohm resistor from my circuit to my negative terminal. So that I can measure the voltage drop through that resistor via the scope, and that's what you're seeing on the screen here in the blue. So if we look at the RMS here, that tells us that we have 20 millivolts RMS, which is actually 20 milliamps, being a 1 ohm resistor draw from our battery at 0.43 volts. So I'll work that out in a minute and I'll add that to the description. Now what we're going to do, I also have a 1 ohm resistor on one side of this LED here. I don't know if you can see that either, but it's there. So when I put this coil on top, ew, and what happened there? That's not supposed to happen, there we go. Alright, it's gone away. I think I've got a loose lead. Yep. So we can see now that we have 20 milliamps in from our battery, 18, and we're getting about the same out. Bit more even. Fluctuating around, I think it's picking up a bit of interference from something possibly. So let's see what those volts are in that coil. So to do that we have to put this over here, stop that from shorting out. Move that. And we're going to have to scale these volts out a bit. And yep, that's right, if that doesn't jump around too much. We can now see that that's at 1 volt RMS for 14 milliamps we're getting out of there now. So we can try and work out our amps off that and compare the watts off that, and compare that to the watts we had just before. Now that's running pretty efficient off the flat battery. I just want to show you how inefficient it is off a not so flat battery. I'm going to take that one out and I'm going to put a more charged one in. This one's about half full. And straight away you'll see there's a bit more brightness there. And we're getting a much nicer looking amps curve on our scope here. But our amps draw out of our battery is a lot more too. We're only getting 28-30 milliamps through that LED, which is probably going at near 2 volts, but it's costing us 300 milliamps. So let's see how many volts we do have going through that LED. And we're going to have to scale out again. And we can see there, if it'll stay still, our RMS is only 0.8 of a volt, 0.88, so we could call it 0.9 for 30 milliamps. For what was nearly 300 milliamps in at 0.6 of a volt, it's just dropped below 0.6. You can see as it drops it does a funny little double spike thing there sometimes, which I thought was a bit interesting. Some sort of resonance going on. I don't think it does that when you take the coil off. They do feed each other a bit. So there you go, that's it. That's about the best we can do with the scope I've got, I'm afraid. I'm a bit suspect that my bandwidth could go faster. I'm right down at the lowest end of my resolution. I think this circuit might be oscillating a bit faster. But I gave it my best shot, and we do have some figures to play with, so thanks for watching.